Hey everyone, in this video, let's take a look at question 128, longest consecutive sequence on Leetcode. This is part of our blind 75 list of questions, so let's begin. In this question, we are given an unsorted array of integers, nums, and we want to return the length of the longest consecutive sequence. You must write an algorithm that runs in O of n time. So let's take a look at the examples that we have here to better understand the question. So in this first example, we have the following, and we can see that the longest consecutive sequence, just remove elements here, it's confusing. The longest consecutive sequence that we can form is 1, 2, 3, 4. 1, 2, 3, and 4. So that gives us the answer of 4. Here, we can form 9 because we can go 0, 1, 2, 3, 4, 5, all the way to 8, which forms a sequence of 9. Now, the challenge here is to do it in a way that runs in O of n time. Now, if you think about it, the way, if this didn't run in O of n time, this would be pretty easy to do, right? Because we can just sort this. We can just sort this. For example, in the first example, if you want to sort it, it would be 1, 2, 3, 4. And 100, 200. And then all we really need to do is just check as we're going through the array, if the element before is equal to the current element minus 1, or equivalently, the element before is plus 1 is equal to the current element, well, then we can extend our sequence. Otherwise, we just restart. So up to this point, it would be 4 as like the sequence length. When we reach here, we see that we cannot like form this. So this one, we will start a new sequence at 1. So let's maybe take a look at how we can do that one. It should hopefully be pretty obvious, but one thing we would need is we would need like a global variable. So this would be like a result, like a global variable that keeps track of like the maximum path. So initially it has to start off at 1, right? Because we can't have like an answer of 0. It doesn't really make sense. We can always have one element, unless actually if nums is empty, which in case we would have 0. So we can handle that case here. So we have res is equal to 1 here. We also have path. So this is like our global path. This is like our current path. And what we can do is we can go through the array, and I will start at 1 because technically I already handled the 0 with like the first element here, right? So I will start off at 1, and then what I can check is I can check if nums at I minus 1 plus 1 is equal to nums at I. If this is the case, then I can increase my path, right? So I will increase path by 1. I will update my result variable to be the maximum, and then that's actually it. In the other case, I need to reset my path by 1, right? And that should be my answer. Now, in the end, I can just return my res, which is my maximum here. Now, one thing we actually have to handle is the case where there's duplicates, right? Because if you see here, like we have 0, 0. So if I was to even sort it, then I would get something like 0, 0, 1, 2. And so this is actually not a problem because this is a path right in itself. But if you were to maybe consider something like this, right? If this was the array sorted, then a real path is like 0, 1, and 2. But we wouldn't form that because when we arrive at the second one over here, then we would reset our path to 1, and then this would just be equal to 2. So in that case, all we really need to do is if nums at I minus 1 is equal to nums at I, well then we can just skip this element, right? We just press continue here. For example, if we process D2, then we have path of 2. Then if we arrive at another 1, which is equivalent to this one, we can just ignore it. And then when we arrive at the 2, we'll see that the element before is equal to a 1, which is all we need. And then we can extend the path to be 3. And so let's go ahead and try to run this. And it does not work. The reason is because I did not sort nums. I will sort num. And I will actually just press submit here. And perfect, it works. So this is a working solution, but it's not O of n, it's n log n because we're sorting. So let's see how we can maybe somehow fix that, right? So what exactly are we looking for? Well, we're looking for paths. So if I give you a random number, let's say this was reordered to something like this, right? Let's say this was reordered to something like this. Let's say we start on the 100. Well, what would be nice is if I could understand how much 100 extends into the future in this list. So what I mean by that is if I start off at 100, then the possible path is 101, 102, 103 onwards, right? So basically, I just need to check if 101, 102, 103, and I keep going and I make sure if these items are in the list, then I can extend my path. If they're not, then I'll just move on to the next element and then I'll go from there. For example, when I arrive at the 4, I'll check if 4 is there, which it is, then 5, then 6, etc. Same thing with 200, then I'll go to 201, 202, etc. And then 1, 2, 3, and then 3, 4, 5, 2, 3, 4, etc. So you can kind of see here that one thing we're doing is we're repeatedly checking if an element is in this list here. So that's not the best way. We can actually just convert it to a set. because we don't really care about order. And if we're doing set, that's O1 lookup. So that's actually probably better here. So we'll convert it to a set. And then one thing we could actually do is that notice that if our list was something like this, like very simple, like 1, 3, 4, but maybe a reordered, like 3, maybe like 2, 3, and 1, right? In this case, if I start off at 2, then I would look for 2, I would look for 3, and I would look for 4. So 4 does not exist, so this gives me a length of 2. If I go for 3, 3 exists, but 4 does not, so this would give me a length of 1. And then if I go for 1, 1 exists, 2 exists, 3 exists, 4 does not exist, so this gives me a length of 3. Now, if you really think about it, these, like 2 and 3 is part of 1, right? So I don't really need to process 2 and 3. I can just wait until we process 1, and then just process that one, right? So how might we go about doing this? Well, let's take a look at the code and see if we can figure that situation out. So one thing we will actually need to do is remove this. And we could instead make nums into a set, right? And now what do we need to do? Well, now what we can do is we can go through the elements in the nums, right? We can go through the elements in the set, and we don't really care about the order here. So for num in nums, right? So at this case, so let's say we start off with something like, this. So now num is equal to 2. Now what I want to do is I want to basically go forward as much as I can, and I want to see if 3 is in the set, if 4 is in the set, if 5 is in the set, etc. So what I can do is I can do while, maybe not num, let me just create a temporary variable here. I'll call it temp, and I can do something like while temp plus 1 in nums. This is the case, right? So this means that while 3 is in nums, so if 3 is in nums, then what can I do? Well, first thing is I could advance temp to become 3, but I also need to keep track of like how many times I've advanced temp, right? So maybe here actually I can have like another variable. Maybe I can just call it like my counter, and then here I can say c plus equals 1. So I've advanced my counter 1 time, and so I will keep doing this until we eventually go out of bounds. So in this case, like let's say my array was something actually like 4 and then 5, right? So initially temp would be equal to 2. So temp is equal to 2, c is equal to 0, right? So here I would check if 3 is in nums, it is. So I'll make this a 3. I will make this a 1. Then I'll check if 4 is in the nums, it is. So I'll make this a 4. I'll make this a 2. I'll check if 5 is in nums, it is. This becomes 5. This becomes 3. I'll check if 6 is in nums, it is not. So then we actually break out over here. So once we are out, then what do I know? Well, I know that I was able to go to 5, right? And now that I think about it, we actually don't even need this here because we have access to temp and we have access to the number. So I know my number was initially just 2. So I can actually see here that 5 minus 2 is 3, right? So all I need to do is the sequence. It means we went ahead 3 times, or like 2, 3, 4, 5. So we went ahead 3 times. So I would just increase. I would just like do temp minus num plus 1. And that's basically my answer. So I can do temp minus num plus 1. And this is like how much I went in advance. This is how much I was allowed to like go in advance. So like how long the path is. So I can do something like path length. Path length is equal to this, right? Temp minus num plus 1. Now you may think like if they are exactly the same number, like if we are not even able to go in advance, like let's say it was just something like this, right? So then in this case, we would check temp is equal to 2, num is equal to 2. And so this one would be equal to 0 plus 1, which is exactly what we want, right? Because if it's just one case, then if it's just like one item, then that in itself is also a path. So in this case, like that's all we need here. Now, I need to store this somewhere. So I'll have my result variable equal to 1, and I will say result is equal to maximum, result, and path length. And then in the very end, I can just return result, right? So let's go ahead and try to run this case to see if we get exactly what we need. And we do. Let's go ahead and submit. And you can see that we'll actually keep going and we'll get a TLE. Now, the reason for this one is because, as I mentioned in this case, like if we have like the list 2, 3, 1, right? I don't need to look for 3. I don't need to look for 2. I don't need to look for 3. I can just look for 1. And this is actually very important in like cases where you have like a lot of elements, because imagine in this list, imagine we had a long list, like 1, 2, 3, like maybe something like 9, 8, 7, 6, 5, 4, 3, 2, 1, something like this, right? So then like all of this, like 6, we would look 7, 8, 9. We would look here 6, 7, 8, 9. When we're on the 4, we would look 5. We would look all of this, right? So I only really need to look from the 1. And how do I know I only need to look from the 1? Well, if you think about it, if you look at this, if I'm at the 5, right, then if I can see that a 4 is in the array, then I just need to wait for this 4 to arrive. So I can just check if like my current number -1 is in the set. If that's the case, then this entire thing will be handled by that number. So I don't have to worry about it. But one thing I can do is I can actually check. I can check if num -1 is in nums, then we can just continue. We don't have to handle this entire case. So then let's just go ahead and try this out. And we'll click submit. And perfect, that turns out to be the best solution here. So again, just to illustrate what I did here, if you think about this one, if we're at the number 5 here, well then I don't need to look forward because I can see the 4 is in the set, which means 4 will handle all of this. Similarly, when I arrive at the 4, I can see 3 is there, so I don't need to handle it. 2 is there, I don't need to handle it. 1 is there, so I do need to handle it because 0 is not in the set, right? And so that's how you go about doing this problem. This is the O of n time problem. Set, we just store the list of numbers, so that's also O of n. So it's same O of n time and space. For watching.